Hi, my name is Larissa, and this is the topic of the first and second criteria. First of all, we need to understand there are different types of functions, like the x to the square, x to the cube, and x to the 4th power, where they have different concavities, and these concavities and the form of it can explain they either are positive or negative. Let's do a quick example. Imagine we have a function that is x squared plus 10x plus 16, where the positive x squared indicates that it's a positive concavity. Then, first of all, we need to take out the derivative of the function, that in this case will be 2x. Then, we equal that derivative of the function to 0 to take out the critical value, in this case, minus 5. Then, we do a little scale where we can indicate how it can be visualized in the graph. Next, we take the second derivative of the function we have, and in this case will be 2x, to take out the inflection point. But if we equal to 0, we will see that there will be no inflection point in this case. Then, we can see that is only one concavity, then in this case will be positive, that is, until negative infinity to positive infinity. With the little scale that we do before, we can do the intervals, which have the decrease interval, that in this case will be since negative infinity to minus 5, and then the increasing interval that will be minus 5 to positive infinity. Now, to sketch a graph, we need to first indicate the y and the x value. So, in this point, we need to substitute the value of the critical value in the formula that we just have. And then, we end with a value. Then, we sketch the graph until we indicate where our point will be. In this case, will be minus 5 and minus 9. We do a positive concavity, and that's all. If we can do exactly, the graph will see like this. Now, a second example that it will be more complex, where the function will be minus x to the 4 minus 8x to the cube minus 22x squared minus 24x minus 4. In this case, the minus x to the 4 will represent like an m in the graph, and this will be negative. Then, first of all, we take out the derivative of the function, where we equal to 0, and we take out the critical values of the function will be minus 3, minus 1, and minus 2. Then we scale a little graph where we represent where the values will be in the graph. In the second point, we will take out the second derivative of the function to know how many inflection points will be. In this case, we have 2 inflection points. They will be x equal to minus 1.42 and x equal to minus 2.8. Then we use the little scale that we do to find out the intervals. We're decreasing and increasing intervals. The decreasing intervals would be minus 3 until minus 2, and then minus 1 to positive infinity. Then the increasing interval will be since minus negative infinity to 3 and minus 2 to minus 1, where you will indicate it in the graph like we have here. Then we see how the concavities are. It will be positive or negative. The negative first will be minus the infinity until the inflection point, and then the inflection point to the second inflection point. Then we have the second inflection point to positive infinite. In this case, it will be negative 2. To sketch the graph, first of all we need to put the function to identify it, and then substitute the x with the critical values. First of all, like minus 3, we substitute all the x that are found in our function to find the answer of the y value. Then we do the same with the others until we have all of the y values. Then we scale the graph with y and x, and then we put our values. First, a maximum point, there a minimum point, and then again a maximum point. And we indicate the m that we just said about the negative. And that's it. If we can do it exactly, the graph will see like this. Thanks for watching this video. I hope you like it and I hope it will be useful.